grandparents give you a check for your birthday for $650, and you want to start saving money to buy a new laptop. You find a certificate of deposit that earns 1.3% interest compounded quarterly, and then we're going to answer these questions. Well, the most important words in this problem, and that's what you have to look for when you're taking the test. In this particular case, the most important words are compounded quarterly. And compounded quarterly means that we have to use this formula there. In fact, the formula that I just circled, if you see annually, the word annually, the word semi-annually, the word quarterly, the word monthly, the word daily, requires us to use that formula that's circled. So we know a little bit of information about this, and what we're going to do now is answer question B, which says, after 8 years, how much money will you have in your account? We want to show the setup of the model that leads to your answer, and we want to round to the nearest cent. Well, first of all, our P, 650. That's how much money we're starting with. And we find a certificate of deposit that has an interest rate, there's our R, of 1.3%. Well, remember, this is in terms of percent, and we need to rewrite this as a decimal. So we're going to take that 1 and we're going to move it 1, 2 spaces to the left. And when we do, this is going to give us 0.013 for our decimal. We still have N to find, and compounded quarterly gives us the N. So I'm going to infringe on my space down here in C, but compounded quarterly means that interest is calculated 4 times a year. And finally, in part B, it says, after 8 years, how much money will we have in our account? So I personally find it helpful to write down what we know before I put it in the formula. If that works for you, good. If it doesn't work for you, don't do that. But we're going to fill it in. 650 times 1 plus 0.013 divided by 4 to the 4 times 8. Now we're going to take out our calculator, and we're going to type this into our calculator. 650 times 1 plus 0.013 divided by 4, close the parentheses, to the 4 times 8. So let's round to the nearest cent. That means that we're going to look at this 8 here, and that 8 is going to determine that we need to round that 1 up. And we're rounding it up because 8 is 5 or higher. So I have to squeeze it in a little bit, but it's $721.12. That's how much we'll have after 8 years. So now, part C. Determine algebraically how long it will take for the amount in our account to double. So the question here is, how long? That's the important words right there, which I can't circle very well. But now what that means here in problem C, which I'm going to do that, is that we don't know the time on this one. But we do know the A, because it says how long for it to take our money to double. Well, ask yourselves, what's $650 double? It's $1,300. And if you don't know that, then you just take 650 times 2, and there's the $1,300. And we're going to fill in what we know back into this formula. Same formula. This time it's 1,300 equals 650 times 1 plus 0.013 divided by 4 to the 4t. How long? We need to find the time. And if you've been working on this packet, if you've been doing all your practice, isolation is a key to solving these correctly. And inside this problem is a check and balance. Because the first thing we're going to do is we're going to divide both sides by 650. And when we divide both sides by 650, we get 2. Double. How long does it take for us to double? This is 1 plus 0.013 divided by 4 and 4t. I want to check on my calculator, and it might work and it might not work. Do we have a nice number to work with within that parentheses? If not, you do not want to round that number. Well, let's find out. 1 plus 0.013 divided by 4. And I'm going to use it. Nice enough number. It stops. It's not a big long decimal. It's not a repeating decimal. So instead of writing what's in the parentheses, I'm going to write 1.00325. To the 4t equals our 2. Well, really the whole idea behind these logarithms is that we use them to solve when our variable is an exponent. So 4t, that's the exponent. It has a variable in it, and consequently, that means that we need to put a log in on the left, and a log in here on the right. It's going to be log of 2 equals log of 1.00325 to the 14. We're going to take our power property. That means we're going to take the 4t, and we're going to write it out in front of the logarithm. So now what we have is log of 2 equals 4t times the log of 1.00325. Eventually what we're trying to do is we're trying to solve 4t. But right now what we're going to do is we're going to divide. We're going to divide the left side by log of 1.00325 and the right side by log of 1.00325. So we type it in. We're going to leave that number in our calculator here momentarily. It's log of 2, close the parentheses, divided by log of 1.00325. Get that number. I'm going to write down a part of it. Leave that number in your calculator. 213.622. 213.622 equals 14. Well, now, we really want to know the time. So we're going to divide both sides by 4 to finish. And remember, that number is already in your calculator. So we're going to divide by 4. Now is where we'll round. Our time is, I'm going to pull that back up, looking at the 6 to determine what to do to the 5. Because 6 is 5 or higher, it's going to take us 53.406 years for us to double our money.